Father, in the name of Jesus, thank you so much for the gift of life. Thank you so much for this opportunity to get to learn. So I'm going to start a lesson. Welcome you to please come and take charge. May you please enable us to understand. And I pray for the teacher who's going to be teaching us that you may please grant him the wisdom that is required so that we're able to understand. Welcome you to come and be in our midst this afternoon. In Jesus' name we pray and believe. Amen.
Thank you so much, Lisa, for the word of prayer. I want to welcome everyone. Thank you so much for joining. So we are going to look at differentiation 2, and I'm going to take an assumption that each one of us here on the call, at least you have looked at differentiation 1. So that's what we are going to mainly concentrate on. And in this particular topic, these are the areas that we shall look at. By the end of the topic, always you must look at the competence such that you know what you should expect. So we shall look at differentiation techniques when we are dealing mainly with the trigonometric functions. But the most important thing is that you must be able to apply your knowledge of trigonometry to be able to analyze real life phenomena. So that is going to be one of the major things that we shall look at when we are looking at this. Now, the 4 important things we are going to look at, these are the important things here. We shall look at trigonometric functions, we shall look at the exponential, logarithmic, and then the inverse, Maclaurin's theorem, and then further curve sketching. These are the ones we are going to look at, and I'm going to request you that now summarize those 4 such that during the research process, in case there is something you are looking out for, those are the areas that you look out for such that you can acquire more knowledge on them. So you can take note of those 4 areas that we are going to look at in the process of covering this particular one. Yeah. I think people have finished. Are we good to continue? Have we summarized? Okay, okay. People in the chat are saying yes, yes, yeah. Okay. Okay, 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 okay. So those are the areas we are going to look at. Then I have there my first activity. You can read through. And then in case you have any idea, feel free to share with us. Feel free to raise up your hand and then you give us how you think mathematics is linked to music. Feel free to give us a scenario. You can give us something you think that by doing so, math is being related to music. In case you have any idea on how we can have math or how you have seen math being related. Yes, Gilbert.
For me, I think math and music are linked in the way that if you look what for some music to be interesting, it must be flowing in a logic way. It must be logical. And for mathematics, to get correct solution or to come up with the correct procedure or working, you must be logical. So I think both both math and music must be logical. That's how they are linked or related.
Okay, thank you so much, Gilbert, for the submission. Yes, Francis?
I think math is related to music. I think math is related to music in a way that it is used to tell durations of certain songs. Yeah.
Okay, thank you so much, Francis. Tekino, and then our last one will be Musa. Musa?
I practically would think music and mathematics are related in a way that both of them need perfection and practice.
Okay, okay. Thank you. Tekino?
Yeah, I think math is related to music because to me, music is done basing to daily expectations, whereby even math is being applied in daily life.
Okay, okay. Thank you, Tekino. Last, Lisa?
Okay, so I think both music and mathematics contain patterns and rhythms. They both contain frequencies. You know, in music, there are usually patterns, like music can be without a pattern. So it's the same with mathematics. So I think that's how they're related.
Okay, thank you everyone for the submission. Now, in the chat, can everyone put for us a music instrument you have seen or any instrument of music, the one that you can play? You can just place it in the chat. Any music instrument. Someone has put guitar, trumpet, keyboard, piano. Okay, good, good, good. Yes. For me, let me put these ones. I don't know whether people know the name of these ones. In case you know the name, you can tell us in the chat. Yes. Now, behind these instruments you are seeing here, there is some mathematics. And when we are looking at trigonometry, we are going to be able to see the mathematics that is behind this. So when someone tells you that I've gone to the studio to record a song or to do this particular thing, there is a lot that takes place. By the time someone comes up with a song, before you make your comment on a particular song that maybe something has not yet come out, just know that that person has spent sleepless nights just perfecting that 3-minute video you are seeing. So sometimes it takes a lot of time, but these are some of the instruments that we are going to see how they are applied to mathematics. So behind this instrument, when someone plays it, the mathematics you will see behind, this is the mathematics. And when you look at this graph, this is a mathematical graph we can analyze and we can be able to predict that at this time, this is what is going to happen. At this time, this is what we are going to happen. That when someone places this thing, this is what will happen. So this particular is called adungu. So when someone plays adungu, the mathematics behind is here. And even there is some physics here because you can be able to see the troughs, you can be able to see the crests. So this is the mathematics we are going to focus on whenever we are looking at the trigonometry. So where are the applications of these trigonometric functions? When you look at the photos here, you can easily notice something. One of the things you are going to notice is that those who have been to the beach or those who usually go to those areas, you have been able to see these kinds of patterns here, like this. These are mathematical curves that we are going to look at. Still, even when you come here, you will see that here it is up, here there is a valley, then here it goes up. Still, this is a mathematical one, that when a crest and a crest come together, this is what happens. That when a crest and a crest meet, they'll form a bigger crest. When a trough and a trough will are formed or meet, you'll find that now the trough has become a bit more deep. So those are mathematical ideas behind, and they help us a lot when it comes to modeling of trigonometric functions. Now, what are some of the areas where this topic is being applied? So what are those areas where you should expect the scenarios to come from? So you'll find that in this particular topic, a scenario can come from temperature modeling. It can come from tidal measurements. It can come from motions of springs and pendulums, but also it can come from electromagnetic spectrum. Now, this is the physical bit of it where we can apply some of this. But the key idea you need to look out for whenever they talk about this trigonometric function is that, is it bringing out an idea of a curve? If as long as you are able to see something like in a curve form, then it means that behind there is a trigonometric function you can mod from it. In case I talk about springs and pendulums, let me pause a bit and I share here my screen. Hope you can see my screen. What happens that when this is our spring, so when you look at it very well, here it exhibits a trigonometric kind of nature. So let me start it. So when you start it, that's what happens. So at the end of the day, you are able to see those different trigonometric functions. So the graphs you are seeing that are being formed on the screen, those are trigonometric functions. So that's why we are saying that one of the applications where you're going to find is that you're going to find an application when it comes to springs, because these graphs that are being formed, these are trigonometric graphs that we can use to model something. Yes, so this is one of the applications where that we are going to be looking at. The same thing happens to electricity and other particular areas. So you'll find that we shall have quite a lot of applications in those different fields. Okay. Now, what is our aim by the end of this session? So by end of this session, this is what we are going to look at. We are going to look at how do we derive the different trigonometric functions? How do we get their derivatives? That's what we are going to focus on. But in our scenarios, these are the different areas that we shall look at. We shall look at the engineering side. How do they use those trigonometric functions? We shall look at vibration of springs and machines. Sometimes some of you, when they're reporting, let me say, when they're reporting earthquake, still there is an instrument that measures the earthquake, the magnitude of the earthquake was this. That's why it destroyed. There is like a kind of seismic machine whereby the moment the earthquake happens, for it will make a mark like this. So you may find also applications in waves, but also in oscillations. So those are the things that where you're going to find the scenarios originating from those particular areas. But here, don't look at this and say, hey, but I'm not a physics student. No, what is important is you being able to know the different areas and how to approach them. Okay. Yeah, I'm going to start with this. When you look at my graph, I'm going to first take you through one area. Is that when you in obtaining what you call differentiation, or whenever they talk about differentiation simply means a change in something. So whenever they talk about a change, because you have noticed that change is all around. So we can have a change of position, change in density, change in velocity, change in the power. When it comes to chemistry, you have looked at rates of reactions. In biology, you have looked at growth of bacteria. All those ones are talking about change. So when we talk about differentiation, we are mainly talking about a change in something. So in economics, those who are doing economics, you look at what we call the marginal costs and profits. All those ones are change. Those, when you go into sociology, you will find things like, maybe at school, many times when there is a rumor around school, in case the rumor is a bad one, you'll find that within 3 minutes, the whole school has known about that particular thing, as long as it is bad. When it is good news, it may not travel at a high speed. So you may find that if you want to measure the speed at which that rumor is spreading, or what we call periodic change, then it means that you can use differentiation to measure the speed at which that rumor is going to spread around the school. So all those things are what we call, that's what we call differentiation in simple terms. So when we look at differentiation, we are looking at how quickly one variable changes with respect to another variable. So that is basically what we call differentiation. However, I want also to bring to your attention that they can give you a graph, the way you see this graph, and they tell you that show its derivative on a graph. The way you are seeing this graph, they can tell you show its derivative. Show its change. How does the y and the x change over time? Now, that is one thing I wanted to bring to your attention. Now, the moment you have a graph and they have asked you to show its change or to show its derivative, they are simply asking you, how does the y and the x change with respect to each other? So here, when we talk about differentiation, we are looking at y and x changing, and that's what we call the dy dx. So what we call the dy dx means the change in y with respect to change in x, and simply this is what we call the gradient. Now, in case you have a graph like the one I have here, and you want to find its derivative, its dy dx, it means that you are going to measure its gradient at each point on that graph. So by measuring gradient, it means that I'm going to come here, I measure this gradient, I measure. But the most important thing what I want to bring to your attention here, I'm showing you that it is already measured, and those are the different gradients that we have at a different points. So along the y, this is where we have our gradient, what we call the dy, and this is the dx. Now here, the gradient, when you look at the figures we have here, you notice I have 0, I have 0.6, and maybe I have 1. Then I have negative 0.6, and I have 1. So when I'm plotting, I'll plot, remember this is like pi, this is like 2 pi. So it means that when I am plotting the gradient, here the first one, you see it is here I have 1, 0 and 1. So you'll find that for this particular one, when I'm plotting, I have 1. Gradient is 1. You notice, so it will be here. When you look at the next one is 0.6, somewhere here. When you look at the next one is 0. So that means that I'll be somewhere here at 0. When you look at the next one is negative 0.6 is here. The next one here is negative 1. Negative 1 is down here. So you notice that the graph you're going to come up with, you're going to come up with a graph of this nature, something like that. That's how your graph will look like. And that means that this is what we call the derivative or the dy dx of this particular graph. Kindly let me know through the chat whether we're on the same page or whether you have picked something. Okay, Francis has said yes. Okay, yes. Now, if I may ask people, when you look at this graph, there are basically two graphs you need to know. Oh, maybe two. This graph here is a graph of sine of x. This is what we call the graph of sine of x. And when you look at this side members, which graph do you think we have obtained, the other side? Okay, I'm going to repeat, I'm going to repeat another number. So people are saying, Fahad has said it is for cos x. Ruth has said it is for cos. So that means that when you have sine x, you end up with cos of x. So this is how you do it graphically, in case it is a graphical approach. But allow me to repeat for members that have not picked. Allow me to repeat. Let me use this space to repeat. But I'm going to use another graph now. So what do we do? In case I can give you a graph of this nature. The way it is here, I give you a graph like this, and I tell you, this is my y, and I tell you this is x. Now, in case you want, I tell you that find for me the gradient of that graph, or find the dy dx. Now, what do you need to do? You need to know that, one, I want you to remember, when we are finding gradients, is that whenever I'm moving up like this is what we call a positive gradient. When you move down in this form, down the slope, this is what we call a negative. However, when I have a flat line, the gradient here is 0. Now, when you look at the nature of the graph, at this point here is where we have the turning point. So that means that when I draw my line of gradient, it's going to be like this. So here my gradient is going to be 0. Members, when I'm coming down here like this, which gradient are we going to have? Is it negative? Just tell me negative, positive. Put in the chat. Which gradient shall we have? People are saying that is negative. Good. So here we shall have a negative gradient. Negative. So when I reach here, everything here is negative. Here, you notice that the gradient is going to be 0 because it is a line. Then when I reach here, I will draw my tangent. The gradient is going to be positive. Then here, it's going to be gradient 0. Then here, it's going to be gradient of negative. Now, when I'm drawing its derivative, I'll just come here. When you look at the first one, here, this is where you place your dy dx. And here, you remain with your x's. So I'll put here 0. Allow me to just put here maybe to show that this is positive, and then down I have negative. Now the first one was 0. So I'll come here and I plot that this is 0. Let me change the color. Then when I go to the second one, I had negative. So negative is down. I'll place negative here. When I go to the next one, this is 0. You are not seeing, so this is 0. So 0 means that that's like where you have the turning point. Then this is positive. It means that my graph will go up. Here it is 0. It is 0. That's like where you have the turning point. So you are going to have something like this. So at the end of that day, this is where you started from, and then you went here. So you're going to find that your graph is going to come like this. Something like that. And this is what we shall be calling its derivative. Members, are we on the same page? Kindly let me know through the chat whether now we are picking. Okay, from the chat, people saying now we're on the same page. Perfect. So that's how you can do it on a graphical approach. Yes. Now, the next thing as a mathematician, what you need now to ask yourself, which kind of graph is this? That is now what is important. Which kind of graph, members, is that? Is it for sine? Is it for cos? Put your answer, what you think, in the chat, and we see. People are saying sine, others cosine, cos. Okay, now I've seen where we need now. Let me remind you of something. Now, one thing now you need always to remember here. Whenever, this one, even you take note of it. Whenever your graph is like this, whenever it starts from 0 and goes up, this is the graph of y is equal to sine x. Because it is positive because it has started going upwards. When you have a graph of this nature, which starts from 0 and it comes down and it goes up, still this is a graph of y is equal to sine x. But the only difference, this one went down. So this one is the one of negative sine x. When I have a graph of this nature, now these ones you need to know them like in your head. In case this is 1, when a graph starts from up here as its turning point and it comes like this, like this, like this, this is a graph of y is equal to cos x. When a graph comes like this and starts from down negative, but still it goes up like this, like this, like this. Members, tell me, which graph is that now? The second one, which graph would that be? Shiba, yes. Now that one will be for negative cos. Perfect. Yes. So members, when you look here, this graph here, it resembles, this is what we call y is equal to cos x. So this graph was of cos of x. But the resultant we have obtained, members, which graph are we getting? Which graph are we getting there? For which function is that? Very good, very good. Zion, Claire, Linda. Yes. So that is for negative sine. So that, what does it mean? It means that whenever you differentiate cos, you get negative sine. That is what I wanted to show you. So in case this graphical, someone may bring his tricky question and then you ask, how can I have the derivative? But that is how you obtain the derivative when it comes to these graphical numbers. Let me first take on one question. I'm seeing here someone saying it's a bit lost. Who was that? You can raise up your hand in case you have a question. as people digest. Feel free to raise up your hand. I'll pick you. Okay. Yes, Aisha. Oh, Aisha, unmute.
Good afternoon.
Yes, good afternoon.
Yeah, I have.
Yes?
So I would like to ask, I'm not understood on the graph for,
The graph for?
so I'm trying to differentiate between the one of cos and sine. I'm not understood.
Okay, I've just had something like cosine. I didn't get you clearly.
I'm saying I've not understood. I'm not yet on the line of differentiating the two, the one of sine and the one of cos, and how the negative comes in.
Oh, okay. I'm going to say something about it. Then Francis?
Excuse me, teacher.
Yes.
I got lost on that part of whereby it showed us that when you differentiate sine, you get cos. Yeah. Could you please pardon on that part?
Okay. Let me combine those two at a go. Members, I've said, or what happens is that in case you have a graph of this nature, this is our graph, what you need to know is that you need to know the nature of the gradient of that curve. When a graph is at its turning point, it is 0. That is 1. So when you look at this graph, when you are getting the gradient at a curve, always we draw a tangent, a line that just touches that curve. So when you look at this curve here, you note that its gradient in that direction is going to be positive. However, when you have a flat line, it means that the gradient is 0 because the change in, you know that gradient is given by the change in y out of the change in x. But since here it is a flat line, it means that y is not changing. So it means that it is only x that is changing. That means y is 0 out of the x, which will give you 0. When I'm coming down, it's going to be my gradient as a negative. So when I'm plotting here, your task is to know that this is positive and this is maybe negative. This, because remember, this is always your gradient, your dy dx. So the first one you had a positive, you notice, So positive, I'll come and I put it here. Then the next one was around 0. This is why like you have your 0, gradient is 0. The next one was negative, negative is here. The next one was 0, so 0 is somewhere here. The next one here, this is like, this is positive, the positive was here. So when you plot, you are going to come up with a graph of this nature, something like that. Now, for you, when you look at this graph, this was a graph of y is equal to sine x. But the resultant you are obtaining is a graph that is going to go like this. And you know very well that when a graph has its maximum at 1, it means that is a cos curve. If the 1 is a positive 1, that is y equals to cos of x. That means that when I have a sine x and I want to get its gradient, I'll get my resultant as a cos of x. So that is the meaning, that sine x gives you a gradient of cos x. When you have cos x, you get a resultant of negative sine of x. I don't know whether that is okay. Is that fine? Yeah, so that is how we come up with that particular thing. Okay, okay. So we are going to continue. We are going to continue. Okay, now we can start. So we have talked about differentiation and what it means. It's just a process of finding derivative of a function. You can let me know whether you want to write it or we are going to continue. But I know you have already obtained you know about it. So allow me to remind you about something. Earlier on, when you are looking at differentiation, you looked at differentiation from first principles. Members, let me know through the chat whether we still remember differentiation from first principles. Kinda, yes, we do. Yes, sir. Okay, some yes, others no. Okay. So, okay. Curious scientists. Okay, I'm going to first remind you about it and then we start. Now, curious, when cos is negative, it starts from -1 here and then it goes like that. That's how it looks like. Okay, now we come here. Now, what are we supposed to do? Now, when we have, I'm going to start with this one. Let me say y is equal to x. Let me say y is equal to, can I use, okay, y is equal to, which one can I use? Let me say 3x squared plus 2. And they tell us to differentiate from first principles because we are going to differentiate all the trigonometric functions from their first principles. So I want us to build from that knowledge. Now we have two ways we can do it. There are those ones who are well conversant with the formula approach. There are those ones who know how to derive it from the other side. So I'm going to use two. But you as a person always choose which approach is easier for you. For you, any approach that is easy is what you go with. So you don't mind, but any that you feel you have understood is what you go for. Is that fine? Okay, so that is what, okay, kindly first give me a minute. So in case I'm to use to derive it, always we remember that differentiation, we are always going to add a small change on the y side and also on the x side. That means that we are looking at how y and then the x changes. Those are the things we are going to look at. So what are we going to do? So I'm going to say y plus a small change in y will equal to 3. But remember, we are interested in the x. We are interested in the x. So we shall have x plus a small change in x, everything squared plus 2. Members, let me know through the chat whether that one is okay. As you excuse. We are going to continue. Now, what we do, I'm going to do it as a side work. Whenever you find these things of squaring, if you are not yet sure, first do it as a side work. So I'm going to come here and have x plus change in x squared. Some of you, at your schools, you use this delta x. It is also okay. So okay, there is no any penalty. If you want to use this, you use this. If you are used to this, you use this. But you do your side work such that you do not make mistakes. So I'll have that into x plus delta x, like that. So when you open your brackets, you know this will be x into x plus delta x, then plus delta x into x plus delta x. So when you open, you end up with x squared plus x delta x, then plus x delta x, then plus delta x squared. So at the end of the day, you'll end up with this. This is going to be 2x delta x plus delta x squared. So that's what we shall substitute here. So allow me to say this is going to be y delta y is equal to 3 into x squared plus 2x delta x, then plus delta x squared, then plus the 2. Now, when you reach here, you can open up your brackets because this 3 can enter. So you get 3x squared plus 6x delta x, then plus 3 delta x squared, then plus 2. Now, always your task, members, make sure that this y here, you make it cross over such that on your left-hand side, you remain with only delta y. So make it cross over this side such that this side you have only delta y. So that means that when we make it, we shall have delta y is equal to 3x squared plus 6x delta x plus 3 delta x squared plus 2 minus y. Because this side it was positive, so the moment it comes this side, it becomes a negative. Now, once you reach at this point, you substitute what is my y? That my y from here, your y was 3x squared plus 2. So that means I'll have delta y is equal to 3x squared plus 6x delta x plus 3 delta x squared plus 2 minus y. Now, some of you make a mistake. So first put your bracket there, 3x squared plus 2. So, such that when you open it, the negative can affect everything, such that you don't make that mistake. So this will be this plus 2. This negative affects both digits inside, minus 3x squared minus 2. So once you are here, now you can notice that there are those things that can die. This one here goes with this. These 2 and these 2 here are going to go away. And always you'll find that whenever you are differentiating from first principles, there is something that must go away. So that means you get change in y is equal to 6x, change in x plus 3 delta x squared. Now, the moment you reach here, then that's when you are going to bring in the idea of limits. So you start now bringing in your idea of limits. And when we are bringing in limits, then you start, but we are going to say now, our limit as delta x tends to 0. It means that delta x squared will also tend to 0, which is approximately 0. Is that when you have a very small number and you square it, still you get a very small number. So that's why we say it is approximately equal to 0. That means that where you have this, the whole of this is going to go away, so you remain with 0. So that means that our change in y will equal to 6x change in x. The moment you remain with this, get this change in x, take it this side, such that we have change in y divided by change in x is equal to x, change in x out of change in x, such that you have change in y out of change in x equals to 6x. Now, the moment you reach here, you bring in your limits. You say now, limits as change delta x tends to 0, delta y, delta x will tend to dy dx. And therefore, you conclude that your dy dx is equal to 6x. Members, let me know through the chat whether we're on the same page. I'm just reminding you whether we are on the same page. I'm going to take on, this is the first approach. I'm going to do 2 approaches. Then everyone takes on what he wants. Yes, Joan. Okay. Can I clean the board? And then I have Yes? Okay. So allow me to take through the second part. Allow me that I go through the second part or the second approach. Now, the second approach is the one of using the formula. Now we know our formula will tell us that f of x, or what we call f prime of x, is equal to limits as h tends to 0, and then we shall have f into x plus h minus f of x out of h. That is the formula. But I know as well, I do understand that when you are at this point here, you can as well, in your school, some of you here used delta x, used like this. It is also okay for whatever thing you use, depending on how they taught you at school. Now here, our y is equal to 3x squared plus 2. Is 3x squared plus 2. What does it mean? It means that your y is the same as the f. So your y always is the same as what you call f of x, equaling to 3x squared plus 2. Now, when you are to use the formula, I will always advise, first look at what you have in the numerator. Work on what you have in the numerator. In the numerator, we have f into x plus h. So you come and say, now I want f into x plus h. Remember your functions, that wherever there is x is where you put x plus h. So that means I'll have 3 into x plus h. Everything squared, then plus 2. Now here, you go on, in case expanding disturbs you, please feel free, take your time and expand well, such that you don't make any mistake. But in case now everything is flowing, it is okay. So I know when you expand, you'll get something like this. But in case things are not yet working out, please expand in a good way, such that you do not make any mistake. So at the end of the day, here we shall have this 2xh plus h squared, then plus 2. Then when I open brackets, I'll have 3x squared plus 6xh plus 3h squared, then plus 2. This is this part here now alone, this part here. Now I have minus fx. So that means that when I have fx plus h minus f of x, I'm going to come here and I say I had 3x squared plus 6h plus 3h squared plus 2 minus my f of x. My f of x was 3x squared plus 2. So when you open, you are going to surely see that there are some things that are going to go away. Let me open like that. So the negatives, this and this are going to go away, the negative and the negative. So still you are going to end up with 6h plus 3h squared. Now after simplifying, please feel free now to go back in your formula and do your number after making it into a simpler form. So I'll have f prime of x will equal to limit h tends to 0. Then up now I have 6xh plus 3h squared, everything out of h. Now, once you reach this moment, you have two ways to do it. You can say that my limit as change tends to 0, h of squared is approximate equal to 0. So where there is h squared here, it's going to die and will get 0. So that means you have limit as h tends to 0, then you come and say this is 6h out of h. Because the other h squared has gone to 0, then at the end of the day, you notice that the h and the h up cancel, so you remain with your answer as 6x. So that is your f prime of x. So that's how we use the formula. People are saying they are lost. Okay. Yeah, like I'm saying, it depends on what your school taught you. In case the school used the first approach, it is okay. Use the first approach. In case your school used this approach, it is okay. Now, people who are lost, I think you use the other first approach and you have never used this. So this one, I've done it for people who use the first approach, the second approach. The other one, I did it for people who use the other approach. Now, for you, choose which approach you used at your school going forward. Yeah. Hope now it is okay. You have understood my idea. So it is not that use this. All approaches are the same, but it depends on what you used at your school. Eh, okay. 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 So I think now we are going to start. Kindly, I think we are going to start. Yes, we are going to differentiate all the trigonometric functions. We are going to, but let me take on this hand. Peter, you can write. Yes, Peter?
Yes, sir.
Yes.
My question is, what if you use the other formula where you drop the power, then you draw the power and you multiply it to the coefficient of x, and then you reduce that power by 1. Is it also okay?
Now, that one works, but here, when they tell you that use from first principles, that is what we expect you to do, like what I've done. That one is just a generic one, of which it cannot work on everything.
Okay.
So that's why you need to know now, what about from first principles? What do you use?
Thank you.
Okay. So you first write what you are seeing on my screen, and then we start. So members, from the chat, which approach should we use? Should we use the first one? We use the second one. You can let me know. You say first, second, and then, but we can use both such that everyone is comfortable. Okay. From the chat, people are saying we use one. So, okay, I will use both, but let me first use one since they are the majority. Okay, now, when we are using the first approach, we have said that we are going to add our egg delta on the left and then on the right. So I'm going to say, what are we going to do? So you add it on the left, add it on the right. That is the first thing we always have to do. So, and I have already told you that your f of x is what we call our y. So that means I can say y is equal to sine of x. Now, when we are adding or when we are differentiating from first principles, we add a small change in y and we add a small change in x. So I'm going to come here and I say y plus a small change in y will equal to sine. Now, this x is the angle, which is x plus small change in x. That is always the first step. And I want you always to take note that always these angles are measured in radians. Never differentiate in case when these angles are not in radians. How do you know that the angle is not in radian? The moment you find x degree, This one means that it is in degrees. It's not in radians. So you cannot differentiate it the way it is. The approach changes on how you approach it. Take note of that. Yeah, and always we shall assume that the moment there is nothing like a degree, you are dealing in radians. Members, hope that first step is okay to everyone. Now, after getting that, what is the next step? The next step now here is having our y taken this side, such that we remain with only change in y. So I'll come here and I say change in y will equal to sine of x plus small change in x minus our y. But your y, we say that y is sine x. So I'll come here and I say change in y is equal to sine of x plus small change in x minus our y, which is equal to sine x. Members, are we still on the same page? Are we still on the same page? Anyone we are leaving behind? People are saying we are good. Okay, we are good. Same page. Now, after that, what do we need to know? When you were dealing with the trigonometry, you looked at something very important, what you call the factor formula. And you said under the factor formula, when I have sine of A minus sine of B, members who can tell us what we get, feel free to raise up your hand. When you have sine of A minus sine of B, what do we get? From your factor formula when you are looking at trigonometry. Anyone to tell us? Prince Ngobi?
Good afternoon, sir.
Yes, good afternoon.
So when I have sine of A minus sine of B, I will get 2 sine into A minus B out of 2 cos A plus B out of 2.
Okay. Out of 2, thank you. Junior? Sorry, thank you, Prince. Senior, you have the same? Matter of hope it is the same.
No,
What do you have?
it will be 2 sine A plus B out of 2 cos A minus B out of 2.
Okay, thank you. I'm going to ask members in the chat to tell us also to contribute on 1 and on 2. Members, which one is okay? Which one deals with that? Someone is saying none is wrong. None? That I think. Okay. Let me get one more member. Ronald Matovu.
I think is cos A plus B out of 2 sine B out of 2.
So for yours is 2 cos
2 cos A plus B out of 2 sine A minus B out of 2.
Okay. Thank you. Okay. I think yeah, the third one. People are saying the third one. Okay. Yeah. Okay, the third one. Okay. I'm on the third. It is correct, the third. Okay. So I'm going to first eliminate the second one they gave us. This second one was for when you have an addition. But what you do always, in case things have not yet worked, you have not yet mastered, please go on and get a logbook and check out for the factor formula. However, whenever you are using those logbooks, it has a way it reduces on your speed of attempting the paper. So that's why we encourage first have them on your fingertips. But I also want to say that there is what we call commutativity. Me having sine x, cos x, it is not different from cos x, sine x. These two things are the same. Now, when you look at the first one, what is very important to look at is this angle here, that the angle is a minus b out of 2. Still, even on the third one, the angle is a minus b out of 2. When you look at the cos, it is a plus b. Also, this is a plus b out of 2. So members, let me know through the chat. Are they the same or they are different? Feel free to tell us in the chat. Are they the same or they are different? Oh, yeah, they are the same. Okay, good. So those are the same things, eh? But I think the one that you are mostly used to is this one. Eh? But as long as whenever you have a subtraction, your cos, you are adding the two angles. That one do not forget. So when you come here, I'm going to come here and I say now, after knowing that this is the substitution I'm going to use, you have to extract your angle A and angle B. So here our angle A is going to be x plus change in x. The whole of this is an angle. Then your B is going to be your x. That means that when we come here in our formula here, we shall substitute our angle as this and we shall substitute our angle B as that. So you are going to allow me now to come here. Hope you know our formula. Let me put it here. Allow me to use the second one because people are more familiar with the second one, with the third one, okay? So we are going to substitute. A, we put this. B, we put that. Alternatively, even I can first do it here. That A plus B. That my A was x plus change in x. My B was x. So when I add, I'll have 2x plus small change in x. Then for A minus B, we know that I have A minus B. Our A is x plus small change in x minus B, which is x. So you notice that x minus x is 0, so you remain with change in x. So that is just side work. So I'm going to come here. You are going to allow me now to clean my screen such that I can have space here up to right. So I'm going to, so when you see me just putting 2, it is okay. So when I come here, I'll have my change in y is equal to, now where there is this one, I'll start with a 2 cos my a, which we have said is x plus small change in x, plus b, which is x, everything divided by 2. Then I have here, I'm going to have my sine, of which my sine now here is going to be x plus small change in x minus x, everything divided by 2. So that's what we have on our this side. So when I go on to expand, I'll have 2 cos. So you notice that here I'll have 2x plus small change in x out of 2. Then you'll have sine of small change in x out of 2, and you have change in y. Members, kindly let me know, are we still on the same page or we are leaving someone behind? Gilbert says, yes, Infinix is lost. Imran, no. Pavin, yeah, I'm lost. In case not really good to go, some are there, some are not. Okay, in case you are lost, kind of raise up. Because I think I may need to take one person to let us know where they are lost. Anyone who is lost, ready to tell us? Such that. Yes, Jimmy.
Sister, where I'm lost from is, okay, firstly, in my school, we did not learn about the factor formula. Then also, okay, where it's hard to understand is the second red line. After you outline that A is equal to x plus change in x, then yes, that second part of change in y is equal to 2 cos in 2. That's why it's really confusing.
Oh, now, okay, you stay on. You stay on. Now, we have said that from factor formula, when I have sine of A minus sine of B. Have you seen this?
Yes.
So you notice that the whole of this is like sine of A. The whole of this is like sine of B. So we are subtracting two sines. You have this sine, and you are subtracting. So when you subtract them, you end up with such an expression. Are you getting? Not
Yeah,
yet?
I'm getting you.
So that's why now, instead of writing sine of x plus change into x minus this, that's why we have put the whole of this. In other words, having sine of x plus small change in x is the same as the whole of this side. Is it okay now or not yet?
It's okay, I've understood.
Okay. Samsung. Okay. I'm trying to get Samsung. Jim.
Yes.
Samsung, you can.
Sir, I'm just also lost there where you are substituting that factor formula of sine A minus sine B. Yeah.
So have you, Samsung, are you noticing that our A is x? Did you understand this part, that A is the same as x plus small change in x? From here. Did you get this part when you pick this angle? Oh, Samsung, I've lost you.
Yeah.
Hope you pick that part. So when I have A minus B,
Yes.
Samsung, where there is A, I put x plus small change in x. Where there is B, the angle for B is x, I say minus x. So x minus x is 0. So that's why we remain with only change in x. Is it fine?
Okay, sir, I've understood you. Yes, sir.
Okay. Okay, lastly, Jim.
Yes, teacher.
Yes.
I'm asking, can you only apply factor formulas, or there's also another method you can apply there?
Now here, the only method we can apply is going to be factor formula.
Okay. Okay, thank you.
Okay. Then maybe lastly, let's let me, okay. Okay, I think there's another Samsung here.
Teacher, if you don't mind, please repeat from the beginning for me.
Okay. Now, for you, allow me to go to the next one. We are still differentiating. Allow me that when I'm starting another one, I'll be doing fresh as your friends are continuing. So I'm going to capture you from there. Okay, now we continue, members. Now, members, when we reach here, this is where we bring in the limits. So when at this point, we are going to bring in the limits. But also I want you to take note that as the delta x tends to 0, what happens is that when I have sine of a very small angle changing x out of two members, this one will be approximated to changing x out of 2. Please take note of that. Whenever you have sine of a small angle, in case even you feel, in case you forget in class and things are not working out, for you say sine of very small angle like 0.00000 what? You'll get a very small thing. So whenever we have sine of small change in x, it is approximated to that particular angle we have. So that means that where we have sine of this, we are going to replace it with this. So that means I have change in y is equal to 2 cos of 2x plus change out of 2. Then where there is sine, members, don't add it here. I'll have delta x out of 2. Now, in case you want to simplify your mathematics quickly, feel free that these two here you are seeing here and these two here can be reduced. And therefore, when you reduce, it means that delta y will equal to cos of the angle, which is 2x plus delta x out of 2. everything times delta x. Hope that is okay. This is x, this is delta x, and this is our 2. Now at this point here, what do we need to do is that you are seeing this delta x and the change in y. You can remove this delta x by saying divide by delta x, divide by delta x. So that means you are going to remain with change in y out of delta x will equal to cos of 2x plus delta x, everything divided by 2. Let me first pause there and people tell me in the chat, are we still safe? Are we on the same point? Are we on the same page? Are members speaking? Gabriel is saying that, what do you yes, okay. Yes, those limits are the one that help, like they help you to eliminate, to enable you to eliminate something mathematically. Okay, about we are picking very well. Oh, because okay, here your vision should be how am I forming the y, the x? You must have that in mind, that I must form the y, the x. Okay, Martina says, okay, we are safe. Okay, okay. Now we complete. Now when you reach here, we are going to come and say, what are we going to do? We bring in our limit issues. So we say as delta x tends to 0, our delta y out of delta x will tend to dy dx. So what is going to happen is that where you have here now, look very well, where you have this delta x, here it's going to vanish and it will become 0. Where you have delta y out of the delta x, it will become dy dx. So that means that our answer, we are going to have dy dx equaling to cos of x. Because here you'll have remained with 2x out of 2 and 2x out of 2, the 2 will cancel, you remain with x. So our conclusion here would be that our dy dx is equal to 2 cos of x. So we can write that as I take on some questions. Okay, I repeat, the compound angle formula will not work. The only formula we can use here is going to be the factor formula. Anything with trigonometry from first principles, whatever approach you are going to use, it will draw you back into using the factor formula. Yeah. Why didn't we, even if you divide, remember this division affects everything. Yeah, I don't know whether I can now remove something from here such that I can say something about that. Hope members had finished writing this. So the division, like here members someone is asking at this point here. I don't know why my pen is bad. Okay, let me first sort this pen issue. Okay, you'll be writing. So here, when you divide, like when I have, okay, you first write, I'm going to explain that. But when I have cos x and I'm multiplying by 2, this 2 divides everything on both sides. So here and here it cancels. Because this is multiplication, it's like having 2x then times 2 is equal to maybe y. So when you divide by 2, this 2 only cancels with this out of 2. So it does not affect this. because it is multiplication. So that's why it did not affect the cos. But members, we are still doing other numbers. So factor formula should be at the with you. Where does 2 cos? I'm not seeing the 2 cos. Where is the 2 cos? From where is the 2 cos? Where is the 2 cos? Martina, I've not picked which 2 cos you are talking about. 2 cos, 2 cos. The final answer is the y dx. I think, I don't know that people are saying here. Here, you don't know my body is not doing well. Like here, the answer is cos xc. This is cos x. You have remained, these 2 and these 2 cancel. So you remain with cos x. I don't know that it is okay now. Okay. Okay. Okay, we try another number. Okay. Which 2x? I'm not saying. Okay. Okay, let's do another example. Another example. Okay, let me first do another. No, it's not difficult. This being our first number, I think that's where the problem is coming from. Hey, I had already changed. Okay. Allow me to remove this and I give. Okay. Now I'm going to change this and allow me to, that this time round, we are going to have, no, but first, excuse me, I don't know why. Let me first stop sharing a bit and I first sort out this screen issue. Okay. I'm sharing again. Okay, better now. Now, this is the one we are going to work with. Now, we follow the procedures. Now, I saw a question about limits. In limits, when they talk about limits, a limit means that what value do you get when that function is approaching a certain point? That is the meaning. That as you are approaching this particular one, what particular value do you get? That is the meaning of what we call the limits. In simple terms, let me explain it like this. That if this is our sine curve, what happens? This is where we have 0. That's what I want to. That as I'm getting, like when you look at this, let me say this angle here is 10, this is 20, this is 30. You note that for the sine curve, if I am moving towards 0, that whenever you move towards 0, you notice that the angle keeps on reducing. As I move towards 0, the angle keeps on reducing, reducing, reducing. So limits means that what is that particular value, or what value do you obtain as you get close to a particular point? Now, in limits here and differentiation, we always look at 0. What is the nature of that particular point as you move towards that point? And I want now to bring it to your attention There are basically three things you need to know. That whenever you are dealing with sine of any angle theta, whenever this sine is approaching or tends to 0, here your angle will be approximately equal to that angle. But in case it is cos, then cos is different, because whenever you have cos, you know that the graph for cos goes like this. So for it, as the angle tends to 0, instead the cos has a maximum. For it is at 1. So you need now to know, am I dealing with cos? So cos of a very small angle here, as it tends to 0, for it, it will be instead a 1. But if you have a very small thing and you have squared it, that one is approximate equal to 0. So those are the three we are going to be dealing with. When I have sine, I'll get that same angle. In case I'm dealing with a cos, that particular thing will always be approximated to 1. Kindly, first let me know whether we are good now to continue on those particular ones. Are we good to continue? Okay. Okay, now we start on this one now. Here, pay attention, because I want to give you one more when it is you people doing it. Okay, now what are we going to do? Still, we do the same thing. We say the first thing you let, here I'm going to say my y will equal to sine of 3x. So we have said here that always have a small change added on y, have a small change added on x. So that means I'll say y plus small change in y will equal to sine of 3. We add on x. Members, don't do a mistake. So it means we shall have x plus small change in x. Don't do this mistake of you saying 3x plus small change on x. It is x that changes, but x is being magnified by 3. So this is wrong. Don't do it, or avoid doing such, or never do that. Yeah. So you add on x. Okay. Now we continue. We said when we reach here, get the y come this side. So we shall have change in y is equal to sine of 3. You can open brackets, no problem. 3x plus 3 small change in x, then minus y. Then here we shall have change in y will equal to sine of 3x plus 3 delta x minus our y, which is sine of 3x. Now, people who have not yet done factor formula, here, look at here you have sine. Here you have sine. So when I have a sine of A minus sine of another angle, here when you expand this, you end up with 2 cos of A plus B out of 2 sine of A minus B out of 2. That one, have it in your head. In case your things are not entering, check your logbook, but that one is a must. And why do we bring in such concepts? Is that we want to simplify, because I want to tell you mathematically, there is no way you can simplify this left hand until when you go this side. So for this particular one, identify what is your angle A and what is your angle B. That is the next thing. You relate that here, my A, what is sitting where A is? That what A is this. What is sitting where B is? That B is here. Let me first pick on a hand. Yes, Imran.
Excuse me, sir.
Yes.
I'm kind of confused because you have taken the y the other side, but you have said that small change in of y is equal to sine bracket 3x plus 3 small change of x minus. Now, my question is where this sine 3x is coming from.
Are you seeing from here?
Oh.
Are you seeing this?
Yes. So
Hey,
meaning
so we
the
say
f of x, the f of x becomes the y.
perfect.
Okay. Thank you, sir.
So whenever you find f of x is always y in simple terms. If you remember your functions very well, so your fx is always your y. Okay. Someone is saying the factor formula. Now, the factor formula at this point, we are not deriving it. So for you, you have to just know how it is stated. But now we are looking at how it is being applied. Yes. So for you to know that whenever I have a sign minus a sign, this is what I get. So here I'm going to extract our A. Our A is the same as 3x plus 3 delta x. Then your B is the same as 3x. Now the moment you reach here, come in your factor formula. Here where there is A, put what you have. Where there is B, put what B is, like that. The rest, please feel free to, if you have already understood, please go on and complete the number, as I hope the ones who are not yet there. Yes, Lynn, Tammy. Yes, Tammy? Oh, okay, I'm failing to get Tammy. Okay, we are going to continue. So here, members, we shall have delta y is equal to sine, let me write here. We shall have delta y equals to, now I'm substituting this side, so we shall have 2 cos, up there I have 3x plus 3 delta x, then plus 3x, everything out of 2. Then I'll have sine, I'll have 3x plus 3 delta x minus 3x, everything out of 2. Now here, you do your mathematics. So this will be 2 cos 3x plus 3x, we get 6x plus 3 delta x out of 2. Then here, I'm going to end up with sine. I'll have 3 delta x out of 2. Why? Because 3x minus 3x is 0. So I remain with that 3 delta x. But like I've told that whenever delta x tends to 0, the behavior of a sine curve is you get a small thing. So you can say that as delta x tends to 0, it means that out of 2 is approximately equal to the angle. So at that point, you substitute wherever you have the sign of this, you put this. So that means we shall have delta y is equal to 2 cos of 6x plus 3 delta x out of 2, then times, here it is a multiplication, then 3 delta x out of 2. Now feel free to do your mathematics here, that when you look at these two here, and these two can cancel. In simple terms, it's like having 2 into x y out times maybe a half. These two and these two can cancel because this is multiplication. So that means that we shall end up with delta y equals to cos into 6x plus 3 delta x out of 2, then times 3 delta x. Now, once you reach at this point, first remove this delta x, divide it on both sides. Divide this side, let me do it like here, delta x, divide by delta x. So delta x here and this one cancel or reduce. So you end up with delta y out of delta x is equal. Now here you notice that here it's going to reduce, so you remain with cos of 6x plus 3 delta x out of 2, then times the 3. But this 3 is like having cos theta and a 3. So this is the same as writing the 3 first and write cos theta, because this is multiplication here. But this 3 does not multiply the angle, so don't do the mistake of multiplying the angle, no. So that means that here you can write it in another beautiful way by writing the 3 first. So I can write it as change in y out of change in x equaling to 3 cos of 6x plus 3 delta x, everything out of 2. Now the moment you reach here, that is when now you start saying as delta x tends to 0, you say as delta x tends to 0, then it means that your delta y out of delta x will be tending to the y, the x. Now this angle of delta x, that one is going to tend to 0, or it's going to become 0. So you remain with your dy dx equaling to 3 cos of 6x out of 2. Now by 2, 1, by 2, 3. So you end up with 3 cos of 3x. And that is the answer for our dy dx. So Alex, your answer was correct. Let me take on one hand from Infinix. Yes, Infinix. Infinix? Okay, I'm happy. I'm seeing people had obtained the answer. Okay, let me take on from Vincent and then Alexis.
Thank you, sir.
Hmm.
Sir, you say that you have two methods for this. Differentiation using the first principles, and you have given us only the first method. Do you have the second method?
Okay. I'm going to use the second method on the next number I'm going to give. Alexis? Tammy?
So like as in sir, on the second step,
Hmm.
So is it a must for us to always add the small increments of y and the small increments of x?
Yes, always you have to add a small increment in y and a small increment in x as a must.
Okay.
Okay. Susie? Okay. Those who have understood, I have another number there. Y is equal to cos x. So those who have understood the concept, let's be trying it. Yes? Okay.
Some still
Susie. Oh, sorry. Susie, come again.
confused on how you obtain the answer. The answer. How did you obtain 3 cos 3x?
From which point did you get lost?
The last point.
Is this point here okay?
Yes.
Now, are you seeing this delta x here?
Yes.
Now this one goes to 0. Now when it goes to 0, inside you remain with 6x out of 2. So by 2, 1, by 2, 3. So that's how we obtain that 3x.
Okay, thank you, sir.
Okay. Members, I think okay, let me do the second method using for this number here. But I want members who have understood the other first approach. Please go on and use the first approach. I'm going to use the second approach of the formula A. So, like we have said, iPhone, we are trying to find out what is the behavior of this function. What is the behavior? How does it behave as you tend to a given particular value? Yes, but which at one point, still in this particular topic, there is something you'll cover in curve sketching when you're looking at the behaviors for the different curves. Okay, so I'm going to use the formula, members. Please take note, it's what I'm using. Now, since I have y is equal to cos x, I can write this in terms of f. So I can say f of x is equal to cos of x. Now, at this particular point, we know that our formula will say f prime of x will equal to the limit as h tends to 0 into f of x plus h minus f of x divided by h. That is the formula. Now, your task is always to find out what is f into x plus h. So, I'm going to first find what is f into x plus h. What does it mean? It means that when you come where there is your angle, where there is x, you add an h. So it will be cos of x plus h. And what is my f of x? My f of x is equal to cos of x. Kindly let me know whether we are on the same page. Let me know whether we are on the same page on that part, first one. Okay, good. We are on the same page. Now, after reaching that point, up here, you'll notice that in our formula, we are going to have f prime of x is equal to the limit as h tends to 0. But up there, we have cos of x plus h minus cos of x. Everything divided by h. Now, when you reach here, the factor formula comes back. You have cos minus cos. So you go back to your factor formula. So our factor formula tells us that when I have cos of A minus cos of B, who can tell us what expression do we get? Cos minus cos. Yes, Alia?
Good afternoon, sir.
Yes, good afternoon.
When we have cos A minus cos B, the result is negative 2. Negative 2 sine into A plus B out of 2. Sine of A minus B out of 2.
Okay. Now, very good. Thank you. Now, when you reach here, you notice that you had your cos of x plus h minus cos of x. So that means that your A is x plus h. Your B is x. So that means you just substitute A and B. So members, we shall have negative 2 sine of x plus h plus x, everything out of 2, sine of x plus h minus x, everything out of 2. And when you simplify, you get negative 2 sine of 2x plus h out of 2 sine of h out of 2. And this one is what you end up with. So that's what is up here. So when I come back to write again, so that means everything up here is going to reduce to that. That's what you need to know. But also we have known, or I've already told you, that when I substitute, now I'm going to substitute, so f prime of x will equal to the limit as h tends to 0. Here we have negative 2 sine of 2x plus h out of 2 sine of h out of 2, everything divided by the h. Now, at this point, you have to remember what you said, that sine of h out of 2, that in limits, as h tends to 0, sine of h out of 2 is approximately h out of 2, the angle. So where you have sine, that's what you're going to place. Where I have this sine here, this is what I place. That's what you need to know. So at that point, we shall say that f prime of x will equal to our limit as h tends to 0 of negative 2 sine of 2x plus h out of 2, and then I'll have here my h out of 2, everything divided by h. Now you can do your math. These 2 here and these 2 here can reduce. This h here down and this h here can reduce. So at the end of the day, you are going to remain with limit h tends to 0 of negative sine of 2x plus h out of 2. And that is f of x. Now here, still in limits, as h tends to 0, this h here will also go to 0. So when it goes to 0, what is going to happen is that now I'm going to have, let me use another color here. Okay, let me use this red. So it means that now I'm going to remain with f prime x is equal to negative sine. I'm squeezing. Let me squeeze here. F prime x will equal to negative now sine of 2x out of 2. And therefore, your f of prime of x will equal to negative sine of x. Because 2x out of 2, once they cancel, you remain with x. So that means that when you differentiate cos, you end up with negative sine. So this is when you are using the formula. But still, even people who have used the other first approach, they had to apply this. Yeah, such that they can be able to get the answer. Okay, members, kindly let me know. Are we on the same? Are we on the same page at least? Have we picked something? Are we good to continue? Okay. Yeah, okay. Now, those who are finding challenges, it is an indicator that now we need to look at which you have, why have you divided by h? Because here, we remain with an h, here, up here, because here, you can notice that these two and these two cancelled. But in our formula, there is an h up here. So this h here cancels this h down. But in limits, this h here would tend to 0. So here you just substitute as 0 in your formula. Even if you have cos 3x, you'll still have the same thing. So members, let me know through the chat as I put another number. Oh, okay. Before we start now on the scenarios, because this is now a scenario. Before we look at, let me first side that scenario. I wanted to take you through scenario, but let us first now understand the concept. Okay, members, now for this particular one, which method should we use? The first one or the last one? First. Okay, first. Okay, we are going to use the first method. Okay, everyone now says the first method. Now, if we have such a function and they want us to do it still from first principles, what do we need to do? Still, we follow through. Add a small increment in y, add a small increment in x. That is always the first step. So I'll say y plus small change in y is equal to, remember, it is x that is increasing. So I'll say x plus small change in x. Everything squared, members, plus cos into small x plus small change in x. Members, hope that first step is okay to everyone. Hope that first step is okay. You use any method of your choice, eh? Yeah. Okay, it is very okay. Now, after that, we have said the next thing, take away your y. Take y the other side. So that means you have small change in y is equal to x plus small change in x squared, then plus cos of x plus small change in x minus the y. So your task is substitute what your y is. So that means we shall have small change in y equals to x plus small change in x squared plus cos of x plus small change in x minus y. Put here, open well, such that you don't get into trouble. Something like that. So the moment you reach here, feel free to expand this squared. So the x squared, you are going to allow me to expand it very well as x squared plus 2x delta x plus small change in x squared. Then plus cos of x plus change in x minus open brackets very well, x squared minus cos of x. Then for whatever thing that cancels, you remove it. You notice x squared, because x squared minus x squared. Now, when you look again, there is nothing else that cancels. So that means the rest are going to remain. So that means you have small change in y equals to 2x, small change in x, plus change in x squared, plus cos of x plus small change in x minus cos of x. I've told that whenever you're having trigonometric functions, it is very hard for you to go without using the factor formula. So the factor formula still now comes back here. That these two things, it's having cos minus cos. So you go back to the concept always that when I have cos A minus cos of B, what do I end up with? So always that one should come out very well. That here I'll end up with negative 2 of sine A plus B out of 2, then sine of A minus B out of 2. So always that one, have it in your mind. So now we substitute what your A is and what your B is. So here, members, we shall have change in y equaling to 2x, small change in x, plus small change in x squared, plus. Now, in case you want to reduce on the work, it is okay. So this is negative 2 sine of x plus small change in x plus x, everything out of 2, then into sine of x plus small change in x minus x, everything out of 2. If I wanted to eliminate, I could have eliminated change in x squared, because we know that change in small x squared is approximate equal to 0. Whenever you have change in x squared as delta x tends to 0, this one is approximate equal to 0. So the whole of this one here can die away, such that you remain with the change in y equals to 2x delta x plus, I have remained here with the negative 2 sine of 2x plus delta x out of 2, then sine of delta x out of 2. I don't know whether we are still on the same page, members. Let me first pause as members continue to finish, as I pick a hand. Yes, Queen?
Teacher, my question is that step before. Okay, why is it that the delta x squared has been changed to 0, yet for the 2x delta x does not turn to 0, it has remained there?
Now I'm coming here. Now, what happens? Delta x in simple terms is like a very small number. Is that fine?
Yes, teacher.
Now, when I have a very small number, let me say this times another small and I multiply it 2 times, something like this. When I multiply it 2 times, the answer I'm going to get is going to be is going to be very small. In fact, smaller than the ones I multiplied. Is that fine?
Yes.
So that's why for it, we approximate it to 0. However, when I have 2x delta x, for this particular one, this 2x is a big thing. So when I multiply it with a smaller thing, still I will remain with some. Sorry, I don't know what happened. Okay, but I'm back. But I was answering someone's question, but let me hope it is okay. I'm going to start from where I had stopped. So I remember I had stopped somewhere here, 2x. Yes. Yeah, I had stopped somewhere here, 2x plus delta x. Then I had something inside the brackets, negative 2 sine of 2x plus delta x, everything out of 2, then sine of delta x out of 2. That's where I ended. Okay, let me pick up a hand, but I'd ask people to complete. Juliet?
Okay, so I'm requesting for pardon on that part where you say that sine x squared, sine delta x squared tends to 0.
Oh, no, have not said sine squared. I say that whenever I have delta x squared, yeah, it's like multiplying a smaller thing times a smaller thing. So a small thing times a small thing, you get a very small thing.
Yes.
So that's why whenever you find delta x squared, there you approximate it to 0.
Okay, thank you.
Okay. Samsung?
Teacher, why can't we approximate both delta x squared and delta x?
We don't have delta x squared. Delta what? I didn't get you. Okay. Genesis?
So what I'm asking is, since you had said that as delta x tends to 0, meaning that the 2x delta x could be 0 and we just remain with this thing in bracket, isn't it?
Not really. That one, it becomes 0 if and only if it is squared. So you having 2x delta x, this delta x is a small thing, but 2x has the ability to magnify it, to make it big. So it cannot be 0.
Okay,
I don't know
sir.
that Genesis,
Thank
you
you.
are getting it.
Yes, I've got it.
Okay, so we are going to continue. So still here, we know that as our delta x tends to 0, we have already told you that sine delta x out of 2 is approximate equal to delta x out of 2. So where there is sine, the whole of this, we shall put this. So that means I have delta y equals to 2x delta x. Allow me to put minus 2 here, sine of 2x plus delta x out of 2, then times delta x out of 2. What are you noticing? You are noticing very well that these 2 and these 2 can cancel. So that means we shall remain with delta y equaling to 2x delta x minus sine of 2x plus delta x out of 2 times delta x. Now, what do you do next is to remove this delta x. But please and please remember your mathematics when you are doing it. Take an example. In case I have y is equal to 2a plus maybe 3ab. When I want to remove this b, I make sure I multiply everywhere. So I will say divide. Let me say I want to remove a. I say divide by a, divide by a, divide by a. That's how you divide. So similarly, for this particular one, it means that I will divide here by delta x. I divide here by delta x. I divide here by delta x, such that I get delta y out of delta x is equal to these two delta x's reduce to 2x minus this one and this one reduce. You remain with minus sine of 2x plus delta x out of 2. And then from here, you are going to just say, for my limits as delta x tends to 0, then it means that my delta y delta x will also tend to dy dx. So that means you have dy dx equaling to 2x minus sine of 2x plus 0 out of 2. So 2x plus 0 is that. So you remain with 2x minus sine of 2x out of 2 by 2, 1 by 2, 1. So you remain with the 2x minus sine of x. And this is our dy dx. So that's how you do it in from first principles. Kindly let me know whether we are on the same page. I want to pick on Mass Judith. Mass Judith.
Good afternoon, sir.
Yes, good afternoon.
I was inquiring there where you reached at the 2x minus sine x. I had reached that step, but then I thought it was still in brackets, so most of us were getting the answers as negative 2x sine x. So I don't know if
which two? Which bracket?
No, like exactly at the answer. Some of us had maintained the brackets from on top, right from the top.
From here?
Yes, we did not like take away the brackets, so we ended up getting like inverting the answer, though it was like the same up to the very end.
Like you had this?
Some of us like we got negative 2x sine x, so we just inverted the order. So we're like I'm confused there.
Also, I'm getting confused because I don't know how. Because, like, are you seeing this bracket? You had it, right?
Yes.
Now, even if you continue like that, even if I come here and I put a plus and I put it here, and I continue with it, still the answer will look like this. It means there is something you didn't do well.
I ignored the plus. That's why. Yes, but
Okay.
everything is okay.
Okay, Kai, that's good. Okay. Mogisha?
Okay, good evening, sir.
Yes, good evening.
I just want you to first explain for me why you divided everything by delta x.
You want me to do what? I beg your pardon?
You explain more why you divided the other part by the x. Or delta x there.
At the end of the day, your aim is to find the y dx. So the reason why we divide is for us to be able to form the y dx. So that's why we remove it, such that we can be able to form this expression, how the values of y change with respect to x.
Okay, understood. Thanks.
Okay.
Yeah.
Francis?
Well, teacher, for me, my question is that from the moment you said that, for example, change in x squared, small change in x squared tending to 0. Now, I saw that you also said that small change in x can also tend to 0. Now, why didn't you make it as 0 when you said that 2x times small change in x to be a 0? I didn't understand the question for
Now that is 0. When for delta x to tend to 0 alone, it comes when it is an angle. Is that fine?
Yes.
When you have sine, that means I have sine of x plus delta x. This delta x can come to 0. That is okay. Fine? So that is the assumption we take at the end of the day.
Thank you.
But if you want, because here I didn't want to mix them at a go, but it's well if you are okay, but it comes like after you have made a lot of practice. When you state this assumption, you can have everything eliminated as long as you know how to do it. that this one goes to 0, this one comes to change in x out of 2, you can do it at the same level. There's no problem.
Yes.
Okay. Oppo, I want to give people some numbers that I want you to try out as this lesson. So we are not going to look at the word problems. We shall first master that before we come to these word problems now. I can give you also tan. Let me put for you tan. You are going to try for me tan. But for tan, I'm going to give you a hint. When you are dealing with the tan, members, you are going to first express it in this form. In form of tan is sine x out of cos of x. Then after doing so, then you do y plus your small change in y is equal to sine of x plus small change in x, everything out of cos x plus small change in x. Then after, remain with your change in y as we said, then remain with x plus small change in x out of cos x plus small change in x minus your y. So your y here becomes sine of x out of cos of x. Yeah. So at least I've given you a hint on how you're going to approach when you're having tan. Then you're going to see how the factor formula things are going to start coming up. Yeah. So you'll try out that one for tan, and then we say, feel free, try it, and then you tell me what you have obtained. But let me give you these ones as our exercise. No problem. Next time we can start from tan, but you write these numbers. They are the ones you are going to try out. But from first principles, that's what I want us to do. Okay, I wanted to take. Okay, yes, Oppo, James and Okilol, feel free to unmute.
Hello.
Mm.
Good evening, sir.
Good evening.
Okay, my question was that like I saw the lessons are running up to they are running up to 23rd. That's what I saw. So my question is, what if the internet is shut down?
No, I'm sure it's not going to be shut down. So it is still on. The whole of this week,
sir.
even next week.
Okay.
Teacher,
Yes.
This is James. My concern is all about like when we are dealing like with these trig functions, we first outline that when we differentiate like tan, we get this and this. It will help the members to know what they are dealing with. Yeah, like when you are differentiating like that is a course. You understand when we are working out, we know that I have to get this. This is a must. Yeah, teacher, if you can do that, it can help the rest of the members.
Okay. It is very okay, Matofu. Yes, so members, like I told you earlier, sine will give you cos. Cos will give you negative sine. Those are the basics. And then the rest will follow. But I wanted you to discover in the course of doing this that you are going to discover some things on your own. But whenever you have sine, your answer is going to be in terms of cos. Whenever you have cos, your answer is going to be in terms of sine. At least have that hint.
Excuse me. Excuse me, sir.
Yes.
This was about the tan x. I think I found an alternative where you can use the product rule, or it is a must for us to use first principles.
Yes, here I am still specific. I want us to master first principles.
But I can
Because
use
when you look
product
at
rule
the
as well.
learning, yes?
I can use product rule if I find it easy.
No, like product rule and other rules are going to come in Okay, hope people have finished to write here. But let me first put the answer. These are scenarios we shall work on next time. So here, I expect you to have your answer, what you'll get. It will be, no, but let me not give you the answer. But first I'll post them in the chat. Yes, what I want us to do, or when you, like the syllabus books you received, whenever you receive it, ask yourself, what do they want me to do? Because during the setting, that's where the focus is. They look, say, in a trigonometric thing, what did we want them to do? So when you look here at the learning outcome wanted you to be able to solve something from first principles. I don't know that I can get the syllabus
Understood.
for trigonometry. Here, when you look at the trigonometry, no, this is trigonometry. Let me open that
No, it's
page.
okay.
So
It's okay. I've
that's
understood.
why now you need to master, but those other techniques, we are going to come to them. There is a part where now we are going to start differentiating using other techniques, the quotient rule, this rule, and the rest of that, the chain rule, and the rest of that. But for this particular one, you need to know how do those things come about? How did they come about? So that's what we are looking at. Yeah, because in case something is specific and they have told you to use this and then you use another one, the approach would not be. So that's what maybe I would emphasize on that. Master this, but that discovery, your discovery is correct. It is very, very correct. For turn, it can really work very well. Okay.
Okay. Thank you.
Okay. But I wanted to show you, let me hope I'll get that page here. I think it's the next one here. Okay, as he gets there, let me get Sean, Pavin. You can unmute.
Yes,
So this is
Master.
what we are looking at. That's why I was emphasizing the first principles. Okay, yes, go on.
Good afternoon, sir.
Good afternoon.
Master, the issue was, or I wanted to know is about the ID, because some of my friends are not in the group, but they have the ID. For example, they're in senior 6A, but their ID is different. So when they log in with that ID, it allocates them to the history class. Because someone sent me here that the ID I have are just taken me to the history class.